Hey guys, in today's problem, we are given two strings, called source and target, and both of them have the same length. Our goal is to convert the source string into the target string at the minimum possible cost. Now, the twist is in how transformations work. We are also given three arrays. Original, substrings we are allowed to replace. Changed, what those substrings can become. Cost, how much each replacement costs. So if original of I is AB and changed of I is CD with cost 5, that means we are allowed to replace substring AB with CD by paying cost 5. Let's see how the operations work. In one operation, we pick a substring from the source string. Replace it with another substring if it matches one of the allowed rules. Pay the associated cost. But there's an important restriction is, when we perform multiple operations, the substrings must follow one of two rules. They must be completely disjoint, meaning their index ranges do not overlap at all. Or they must be exactly the same substring range. Same starting index and same ending index. So you cannot partially overlap transformations. This prevents mixing and matching overlapping changes. And the objective is, using any number of valid operations, we must convert source into target. Spend the minimum total cost. If it's not possible, return -1. Key insight: what makes this problem hard? Unlike problem 2976, where we converted single characters, here we are converting entire substrings. That means different substring lengths, multiple possible overlapping replacements. Order of operations matters. We must carefully choose which substrings to transform and where. This turns the problem into a combination of string DP, graph shortest path, careful interval handling, big picture intuition. Think of this problem like this. We move left to right through the string. At each position, we try either matching characters directly, cost 0, or applying a valid substring transformation starting at that position. We always pick the option that gives us the minimum total cost. If at any position no valid move exists, then conversion is impossible. Example 1. Input is source equals ABCD. Target equals SCBE. We're allowed to do character level conversions using the given original, changed, and cost arrays. Let's go index by index. At index 0, source has character A and target also has character A. No change needed. Cost is 0. At index 1, source has B, but target needs C. We have a rule to convert B, C with cost 5. So we apply that. Current cost equals 5. At index 2, source has C, target wants B. There's no direct C-B conversion, but we can do it in 2 steps. C-E with cost 1. E-B with cost 2. Total here equals 3. At index 3, source has D, target wants E. We convert D-E with cost 20. Adding everything together. 5 plus 1 plus 2 plus 20 is equal to 28. So the minimum cost to convert ACB into ACB is 28. Example 2, substring operations. Input. Source equals A, B, C, D, E, F, G, H. Target equals a C, D, E, G, H, H. Here's where substring operations really matter. First, we take substring BCD at indices 1, 3. Convert BCD CDE with cost 1. Next, we look at substring FGH at indices 5, 7. Convert FGH THH with cost 3. This is allowed because these indices are disjoint from the first operation. Now, on the same substring range 5, 7. Convert THH to GHH with cost 5. This is allowed because operations can be done on identical indices. Total cost equals 1 plus 3 plus 5 is equal to 9. So the answer here is 9, and this is the minimum possible cost. Example 3, impossible case. Input. Source equals A, B, C, D, E, F, G, H. Target equals a D, 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 D. We have 2 possible substring transformations. B, C, D, 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 D. D, E, F, G, H, D, 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 D. But here's the problem. If we apply BCD first, indices 1, 3. Then DEFGH, indices 3, 7, overlaps at index 3, which is not allowed. If we apply DEFGH first, then BCD still overlaps at index 3, again not allowed. Since both choices overlap, there is no valid sequence of operations. So the answer is -1. You are given two strings, a source string and a target string, both of the same length. You are also given a list of allowed substring transformations, where each transformation converts one substring into another at a certain cost. The challenge is, you can apply transformations on disjoint substrings, or apply multiple transformations on the exact same substring. And your goal is to convert the source string into the target string with minimum total cost. If it's not possible, you return -1. Step 1. Key observation. This problem has two major challenges. A substring can be transformed indirectly using multiple steps. Transformations can only happen on non-overlapping ranges, which means order matters. So this is not greedy. This is a dynamic programming plus shortest path problem. Step 2. Graph construction. First, we treat each transformation rule like a graph edge. Each original of I changed of I is an edge. The cost is cost of I. If multiple edges exist between the same substrings, we keep the minimum cost. This gives us a directed weighted graph of substrings. Step 3. Shortest path, Dijkstra. Sometimes, the transformation you want doesn't exist directly. Example. BCD ST exists. ST DDD exists. So BCD DDD is possible through two steps. To handle this, we run Dijkstra's algorithm on the substring graph to compute minimum cost to convert one substring into another. We also cache these results so we don't recompute them again. Step 4. Dynamic programming setup. We define DPI equals minimum cost to convert source 0i, target 0i. DP 0 equals 0, converting empty string costs nothing. We iterate from left to right. For each position, if characters already match, move forward with no cost. Try all substring lengths that exist in transformation rules. If a transformation is possible, update DP using the shortest path cost. Step 5. Final answer. At the end, if DP n is still infinity, return -1. Otherwise, return DP n. This guarantees the minimum possible cost. Let's run this with the sample input to verify the logic. Everything looks good. Let's submit the solution. And as you can see, accepted. All test cases passed successfully. If this explanation helped you understand advanced string DP with graph optimization, make sure to like the video, subscribe to the channel, and share it with your friends. I'll see you in the next problem. Happy coding!